Shanmuga Perumal is a faculty member in the Department of Information Science and Technology, College of Engineering, Anna University, Chennai. He has more than 6 years of PG and UG teaching experience. He teaches multimedia communication and networks, mobile and pervasive computing, computer communications and networks, computer architecture, mobile computing, mobile networks, ad hoc and sensor networks, communication techniques, grid computing, programming and data structures, problem solving and C programming. He is a member in several board of exams that include IT Board of College of Engineering, Anna University, Chennai, and board examiner in CSE, Computer and Communication, MCA of National Engineering College, Tamil Nadu. He has delivered guest lectures in various engineering colleges of Tamil Nadu, including National Institute of Technical Teachers Training and Research. He has also attended faculty development programs, seminars, conferences, and workshops. He has many publications in international journals and international conferences. He has filed a patent in India and published his novel idea in the Indian Patent Journal. His research area includes wireless sensor networks, mobile communication, location-based services, and electricity power generation.
Welcome to UGC lecture series in computer science. This series of lectures cover the mobile and pervasive computing. The lecture series cover cellular wireless networks, global system for mobile communication, GSM architecture, GSM protocols, connection establishment, frequency allocation in GSM network, GSM handover, security in GSM, and the general packet radio service, that is GPRS. Today's lecture is about cellular wireless networks. We know that the users are able to move from one location to another location while the call is in progress. So, what is the basic structure of the cellular wireless network and how the users are able to get the service while they are in the move, that we will learn. Before learning the wireless cellular networks, it is mandatory to understand the basic about a data communication network. So, what is a communication first? So, the communication is nothing but the mechanism of transmitting or sending and receiving the information. So, users will send and receive the information. So, network is nothing but a connection of or interconnection of various nodes or devices involved in the communication network. We have the 5 basic important components about the communication network. They are message, sender, medium, transmitter, and the receiver. Message. The message is the information or data to be communicated. Popular forms of the information include text, numbers, pictures, audio, and video. The main objective of any communication network is to send and receive the information. So, message is the very mandatory component. So, users can send the image, video, some mail. So, they are referred as the message or data. The second part is sender. The senders are the communication devices. They generate the data actually. They may be the cell phone, laptop, or some computer devices. So, anything that generates the data is referred as a sender. The third component is receiver. The sender generates the data and transmits it to the receiver. Now, the receiver is another one communication device that receives the actual information. Once again, that receiver may be a cell phone or a final destination or a computer even or some other satellite. So, a receiver receives the data. The fourth component is a very important one, that is known as medium. The transmission medium is the physical path by which the data travels from sender to receiver. Some examples of the transmission medium include twisted pair cable, coaxial cable, fiber optic cable, and radio waves. In any communication medium, the users, that is the senders and receivers, are to be connected through the network. That network may be using the wired medium or wireless medium. So, today we are focusing on wireless medium as we are dealing with the cellular wireless networks. And the last important part of a communication network is a protocol. Protocol is a set of rules and regulations that regulates the flow of the data. It specifies how a sender should generate the data, how a sender should access the medium to transmit the data, and how a receiver should be synchronized with the sender. So all kind of rules are specified and referred as protocol. So the protocol is not common for all the medium. So individual application may have their own set of protocols. A particular wired network protocol cannot be adapted or used as it is for a wireless medium, because the environment for wireless is entirely different from a wired networks. So this is the diagram that explains about the 5 basic components of a communication network. Here this is the sender. Now the sender is generating the message or data. The message is traveling through the medium and the message is delivered at the receiver. So the protocol rule 1 up to n depends on the application. Now the protocols govern both the receiver and sender, including the transmission medium. We have discussed about the 5 important components of a data communication network. So the data communication network is broadly classified into 2 types. One is wired and wireless. Wired networks, here the senders and receivers are connected through the wires. So the transmission media is a cables that guides the information between senders and receiver. The best examples for wired medium are LAN, that is local area network. In local area network, Ethernet cables are used to connect several other computers with the server or something. So wired medium is used in the wired network. The second category is wireless network. Here senders and receivers are connected through electromagnetic waves like radio waves, microwaves, infrared waves. In the wired network, cables are used. In wireless networks, the electromagnetic waves are used. Individual wave has its own frequency as well as wavelength. So depends on the frequency and wavelength, the nature of the wave may differ. So this diagram explains a very simple wired network. Here all the computing devices are connected through the switch using the cable. This is the diagram that explains about the wireless network. In the diagram, the mobile phones are connected with the cell phone tower through the wireless link. So the mobile stations are not connected with the tower through the wires. So further, the wireless networks can be classified into 2 types. The first one is ad hoc networks and the second one is infrastructure network. Ad hoc network is a kind of network. Here the networks does not need any infrastructure. Without the infrastructure, instantaneously the devices can be connected through the network. So the control is not in a centralized manner. All the devices are using the protocols, so that forms the ad hoc network. So any node can be connected with the network without the wire. So best examples, in a conference hall many laptops can be connected, or many mobile phones, they can share the data through the Bluetooth technology. So ad hoc network is nothing but connection of many devices without the wired and even a single infrastructure. Second kind of the wireless network is infrastructure based wireless network. The word infrastructure specifies that some infrastructure, some backbone network is required to form the network. So the actual wired networked resources are extended to the wireless users. That is the main aim. In the infrastructure based wireless networks, we have 2 parts. So one part is comprising of wired network, and the resources of the wired networks are extended to the wireless users through the wireless link. So that's why it is known as infrastructure based wireless networks. The famous standards that follows the infrastructure based wireless networks are WLAN, that is wireless local area network. In IEEE, that is specified as IEEE 802.11, and WiMAX, that is IEEE 802.16, and the famous telecommunication networks like Global System for Mobile Communication, GPRS and UMTS. This diagram explains the basic infrastructure based wireless network. Here this is the part, here all the devices are connected through the wired medium. So this is known as infrastructure network. Here the fixed terminals are connected with a centralized server, and this is known as access point, equivalent to the base stations in the cellular communication. Now these access points are connected with the infrastructure network as well as mobile terminal. Now the access point is one that is using the wireless medium to connect with the mobile users, and the access point is using the wired networks to connect with the backbone network. So the protocols of the wired network as well as wired protocols are implemented with the necessary modifications in the access point. So far we have discussed about the basics of a communication medium and the communication basic devices, and how we are using all kind of informations. Now let us start our discussion about the cellular wireless network. So cellular, they are nothing but the telecommunication systems. So they provide the mobile services. So users are able to make a call when they are in movement. In case of previous telecommunications, particularly about public switched telephone network, the users are forced to be in a fixed location. They cannot move after establishing the call and all. But in wireless communication, especially with the wireless cellular communications, the users are free to move. They can make a call, they can get the internet access, they can send some messages while they are traveling in a car or train, whatever may be. So cellular communication aims to provide the mobility while providing the service. So cellular systems form mobile communications that implement the SDM. So SDM is space division multiplexing. Here the space is divided into number of sectors, and within that sectors the users are provided with the service. Each transmitter, typically called a base station, covers a certain area, or that is also referred as cell. In the context of telecommunication system, the area which is covered by the individual tower is referred as the radio coverage or cell. Now the base stations are deployed in the particular regions to provide the mobility support as well as telecommunication services to its users. The cell radii can vary from tens of meters in buildings and hundreds of meters in cities up to 10 of kilometers in the countryside. So the cell coverage area is depends on various factors, so that cannot be common in all kind of environments. Many factors are influencing the radii size of the individual base stations. The shape of a cell cannot be a perfect circles or hexagons. The shape depend on the environment like buildings, mountains, valleys, or even it is depending on the weather conditions, sometimes even on the system load. The user should understand one thing, that the individual radio coverage of the towers are purely depends on various factors. If the load of the particular cell is very huge, then automatically the coverage will be hugely affected. So typical systems using this approach are known as mobile telecommunication systems. Very famous example is GSM. The cellular systems are containing many systems. So obviously the users, the mobile users noticed only a very few parts of the entire architecture. They know only the mobile stations and the cell phone towers and antenna arrays. In mobile communication systems, a mobile station with a cell around a base station communicates with the base station, and even sometimes the base stations can provide with the communications. Let us stop our discussion at this point. Let us have a short break. Welcome back. Before the break, we were discussing about the basics about the cellular communication systems. Sometimes the users may wonder why the cell phone systems are distributing the different kind of transmitters throughout the entire space. Why don't they have the centralized transmitter instead of putting the towers in various places? And also, why don't they use the powerful transmitters also? Let us discuss one by one. In the conventional radio systems, they will install the centralized transmitters, very powerful transmitters, and they will transmit all the informations throughout the region. But in the cellular communication, we used to see that many towers are installed in various places to provide a better coverage. The reason, using the single or centralized transmitter will fail in the case of telecommunication system. The reason is, the first point is higher capacity. Implementing space division multiplexing allows frequency reuse. The frequency is the scarce resource in case of telecommunication system. In the radio communication system, using the single frequency band, many users are able to receive the communication, the data. But in case of telecommunication system, many users have to be connected with a tower. So simultaneously n number of users may access that facility. So the frequency has to be reused in certain region to avoid many problems. So all the majority of the telecommunication systems are using the frequency reuse. If one transmitter is far away from another, that is outside of the interference range, it can reuse the same frequency. If you assume the same scenario of the radio transmission, what will happen? So all the users will be within a single region, so they cannot use the frequency. If one frequency is blocked by some other user, till that person completes his communication, the other person cannot use. So having the single cell throughout the region will not able to accommodate more and more number of users. As most mobile phone systems assign frequencies to certain users, this frequency is blocked for other users. But frequencies are a scarce resource and the number of concurrent users per cell will be very limited one. Huge cells will add more and more users to the network. That is the main aim of splitting the area into several regions and installing the towers in the individual space. This is the diagram that explains about the basic cellular wireless network. Here F1, F2, F3, they are the frequencies. Now the hexagonal shape is nothing but the area covered by the individual towers, but in practical the towers transmission range cannot be a perfect circle or a perfect hexagons because of the environment conditions. Now using the space division multiplexing, we are able to use the frequencies. For example, here the F1 is used in this cell and the same frequency used here also, but before the two cell regions we are using some other frequencies to avoid the frequency interference. So this is the basic for a cellular wireless network, to use the frequency in the reused manner. So this is also the reason for using the very small cells in the cities, where many and more people can use the mobile phones. And the second aspect is less transmission power. While the power aspects are not a big problem for base stations, they are indeed a problematic for mobile stations. But in case of radio transmissions and all, they used to broadcast the information using the single transmitter, provided the single transmitter are provided with the uninterruptible power supply at all the times. In case of wireless networks, the mobile users are running on their own battery power, so that battery power has to be retained. If a mobile user is making a connection to a very far away located transmitter, then the power or the battery package will be drained very soon. So to avoid these kind of power problems, we are decentralizing the concept. Local interference only. Having long distance between sender and receiver results in even more and more interference problem. Once again, if all the users are connected within a single space with the same frequency, then the chance of getting interference will be very high. If we divide the coverage region into many space, then the chance of getting interference will be very less. With the small cells, mobile stations and base stations only have to deal with the local interference. Robustness. In the centralized concept, if a single transmitter is failed, then all the users will be affected simultaneously. But if you are distributing the service through the region, and if a single tower is damaged, then that will only affect the users belongs to the coverage region of that tower alone. The concept of dividing the space into many spaces, providing the robustness against the failure. So far we have learned the advantages of using the space division multiplexing, but at the same time the space division multiplexing or the concept of dividing the space into several coverage regions also have many drawbacks. We will learn one by one. First one is infrastructure needed. Cellular systems need a complex infrastructure to connect all base stations. Mobile users are to be connected with the cell phone tower, so we need the cell phone tower to cover the entire region, and the mobile stations are connected with the base station controller. Once again the base station controller are connected with the mobile switching center. So the complexity of the entire network is very huge when compared with the centralized concept. So this also includes many antennas, switches for call forwarding and location registers to find the mobile stations, which makes the whole system quite expensive. As the coverage region is splitted into many number of cells, the users have to be provided with a handover mechanism. The moment the user is moving from one coverage region to another coverage region, his location has to be updated immediately. So the paging will be a very complex one. So these are all the major drawbacks of using the space division multiple access. As we already mentioned, the handover telecommunication system has to involve with a very complex handover methodologies. They involve the higher end databases like visitor location register and home location register to keep on monitoring the mobility of the users. Depending on the cell size and speed of movement, the handover can happen quite often. If the coverage region of the individual cell phone towers are very small, then the probability of moving from one region to another region will be very high. Then automatically the handover operation will also be a quite complex one. Then frequency planning. In the centralized control, there is no need to hop the frequency between various bands because all the users will be using the single frequency. But in case of telecommunication systems, the users within the same coverage area cannot use the same frequency. Accordingly, the network service providers has to plan the frequency using concept. So the frequency reuse concept is a complex one. As we are having the very limited number of frequency bands, that frequency planning is very important in the telecommunication system. To avoid the interference, different transmitters within each other's interference range are using the FDM. So in the telecommunication system, the space division multiplexing cannot be used in isolation condition. So it has to be mixed with the frequency division multiplexers as well as time division multiplexers. If FDM is combined with the TDM, then the hopping pattern has to be coordinated. If the frequency division multiple access is used with the time division multiple access, then the hopping between the frequencies will be the complex operation. So the main objective of a cellular communication system is to provide the different kind of frequencies within the single coverage region, provided if they are not using the core division multiple access. If a system is using the core division multiple access, then within the same coverage area all the users can use the same frequency, provided they have to use their own code to separate their own data. The hexagonal shape is only used for representing the concept, but in real the transmission range or the communication range of the individual tower is not a perfect hexagonal shape. And to avoid the interference, the transmission power of the individual devices in the network has to be controlled. If a device is using too much of transmission power, then its communication range will be very large. Then definitely it will affect or it will interfere with the communication range of some other devices. We are discussing how the space is divided in case of cellular communication. Now frequency planning also we have discussed. Next concept is frequency borrowing mechanism. In some telecommunication systems, the frequencies are fixed to the individual cells. For example, the coverage region of a cellular tower will be using the frequency F1 always. The coverage region of a tower T3 may be using the F3 frequency always. So many telecommunication systems are using the fixed, but some advanced telecommunication systems are using the frequency borrowing concept. Here the frequencies are dynamically allocated to the cells. So based on the demand, the frequency will be allocated to the individual cells. In a scenario, you just consider a cell is with a very less load and the neighboring cell is with a very high load, and there is no frequency to be provided. In these kind of situation, the frequency can be borrowed from the neighboring cell to support the overloaded cell. So this is known as frequency borrowing. Borrowing channel allocation is using the dynamic concept of frequency. A dynamic channel allocation scheme has been implemented in DECT. This standard is referred as Digital Enhanced Cordless Telecommunication, and fixed channel allocation is used in Global System for Mobile Communication. In GSM, the frequencies are not borrowed between the cells. The dynamic assignment of frequencies has many problems also. If within the same cell, if same type of frequencies are allocated with the same cell, then it will create a interference problem. So the dynamic allocation of frequencies has to be handled with a special care. So the borrowed frequency can be blocked in the surrounding cells, and if we are using the code division multiple access, all the devices can use the same frequency. So using their own code, they will interpret their own data without the interference. So in the code division multiple access, the users are separated using their code. So individual users are using their own code to send and receive the information. The code division multiple access also ensures the security in the telecommunication systems. The CDM cells are commonly said to breathe. So breathe, the term specifies while a cell can cover a larger area under a light load, it shrinks if the load increases. The term breathe is explaining the range of the coverage region will be varying, depends on the load. If the load is very high, automatically the communication range will be decreased. If the load is less, then the communication region will be in the normal condition. So that specifies the meaning for the cell breathe. The reason for the cell breathing is the growing noise level if more users are in the cell. In the code division multiple access, if we don't know our code, then we will not be able to retrieve our information. In CDM, if the noise level is very high, then the data loss is also will be very high. So the noise will deplete the data signal, and we will not be able to retrieve the data as it is. Mobile stations are further away from the base stations to drop out the cell. These are all the various kind of reasons why we are distributing the cell phone towers through the communication area instead of having the centralized region. Let us summarize what we have learned today. Any data communication needs a set of protocols. Pure wired networks does not provide mobility support to its users. Wireless extends the services to its mobile users through electromagnetic waves. Telecommunication systems use infrastructure based wireless networking technology. Frequencies can be allocated in fixed as well as dynamic manner. Cellular systems use distributed transmitters instead of using single powerful transmitter. Let us pose some questions for our understanding. What is meant by frequency reuse? What are the reasons for the irregular shape of the communication range of a tower? Differentiate ad hoc and infrastructure based wireless networks. Discuss the merits and demerits of the cellular wireless networks. What is meant by fixed channel allocation? With this, we conclude today's session. We will continue our discussion in the forthcoming lectures. Thank you.